In this video, we're discussing the electrophilic addition mechanism of alkenes with a molecule of bromine. Bromine is a nonpolar molecule because both atoms are the same, they have the same electronegativity values. However, when a bromine molecule approaches an electron-rich alkene, such as propene here, there is repulsion between the electron densities of the double bond here, electron-rich alkene, and the electron density around the bromine molecule. So the bottom bromine atom becomes delta negative, electron rich, whilst the bromine atom, which is closest to the alkene, becomes electron deficient. Now, the alkene pi bond can break and attack this electron deficient bromine atom. The bromine-bromine bond breaks heterolytically, so this bottom bromine atom takes both of the electrons. Here is our intermediate. It is a carbocation intermediate. That means it's a positive ion on a carbon. And this is a short-lived intermediate which is very reactive, and it reacts with this bromide which has come from this bromine atom here. The lone pair of electrons on the bromide form a new bond with this carbon, and we get our product of 1,2-dibromopropane. Now, what we haven't discussed in this mechanism is the intermediate, this carbocation intermediate. So, there were two possible carbocations I could have drawn. Why did I draw that one? Okay. So if I draw both of them out, first of all, then we can compare both of them. So this is the one drawn above. And this is the carbocation that I did not show. Both are equal in that they both have the same number of atoms, they both got a positive charge on a carbon atom. The only difference is that here we've got that the carbon atom with the positive charge has got 2 carbon atoms attached to it, and both of these carbon atoms will inductively stabilize this carbocation by donating electrons. This carbocation here has only got 1 carbon atom attached to it, and so it's only got 1 source of electrons from a carbon atom which can stabilize it. We call this a secondary carbocation because it's got the 2 carbon atoms attached to the carbon with the positive charge, and this one is a primary carbocation. As this is the most stable, this carbocation is the more favoured carbocation intermediate, and as such you should be drawing this carbocation when you are drawing your mechanisms.